Hello class. In this lecture I will try to solve a problem on multiple regression. So here is the question I have, in which I have four variables. So the first variable is square feet, and the second variable is number of bedrooms, third variable is age, and the fourth one is the selling price. So if you have such question, this is mostly related to house price. So the first thing is you have to determine what is your dependent variable and what is your independent variable. So these represents the selling price of the house. These represents the square feet of the house. This represents the number of bedrooms, and then this represents the age of the house. So as you see, selling price usually depends on the square feet of the house and the number of bedrooms the house has and the age of the house. So we are trying to form a regression equation where multiple linear regression equation where y hat is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3. So if you see in this, y hat will be our dependent variable. So this is our dependent variable. So this will be the selling price. And then x1 is the square feet. X2 is the number of bedrooms. And then x3 is the age of the house. So we have to get this equation though. So the first, the goal of regression is to first determine what are these beta naught, beta 1, beta 2 and beta 3 values, and what would be this entire equation, how would it look, and is this equation good enough to make predictions for future. So that is another question we will be asking ourselves. And then how important are these, each of these factors are important or not. So that is another question we are going to ask. So the first thing is I will try to get a regression equation. So I will copy this data to our calculation aids. So I will go to our canvas page, go to modules, and then in module 0 I will go to calculation aids, and then in calculation aids I will go to chapter 13 and 14 calculation aids. So chapter 13 is simple linear regression, and chapter 14 is multiple linear regression. So you'll use the same sheet for both the chapters. So you will have this. I will copy this data set to our calculation aid. So I will do control C, and then I will copy it here, somewhere here, control V. Okay, so I have my data. So the first thing is which one is your Y. So you can look at your selling price is your Y. So this is your Y variable. So I will copy this data, the Y, into our Y column, and then x1 is the square feet. I will copy this here. X2 is number of bedrooms. I will copy it here, and then x3 is the age. I will copy it here. So one of the things I wanted you to understand in this is we discussed about this. When we have an equation like this, we wanted to make sure that we don't do we make sure that do we have a qualitative variable or a quantitative variable. So if we have a qualitative variable, we have to introduce a dummy variable. But at this time, if you see these, each one of them, so if you see beta x1 is the square feet. So this is a quantitative variable, and then number of bedrooms is also quantitative, and age is also a quantitative variable. So in this you don't have any uh, qualitative variables, so you don't have to worry about introducing a dummy variable. So now we are in our calculation is we entered these values, and if you see, the first thing is the summary output which we got, which has r square value, which is coefficient of determination, and then we have error, standard error, and observation. So in this we are only interested in r squared value, which is the coefficient of determination. And then we have an ANOVA table here. So if you don't see any values like this, you just need to increase the width of your column. uh, so okay, so that's all. And then this is the regression table. So that is what we have, and if you see, we have the coefficients here. So the first thing is this represents your beta 1, which is let me your b1 beta 1. This represents beta 2, b2, and this represents b3. So these are the slope. This is the slope b1, which is for square feet, and this will be the slope. So this is slope for b1 is the slope for square feet, b2 is the slope for bedrooms, number of bedrooms, and b3 is the slope for the age. So that is what. So the first thing is we wanted to determine whichever model we are developing, is that model good enough for prediction. So the first question is, what is your model itself? So if you look at these coefficient values, that is where you can kind of develop your model. So this is your intercept, which is beta naught. So this will be b naught or b0, and then b1, b2, and b3. So that's how you are going to. So how would your equation look? So maybe let me uh, copy these values. So I will copy these values into our Excel sheet here, and so these are our coefficients which I'm copying. So let me okay, I will copy these coefficients. So I will just copy the values. So what it means is, this is our b naught or b0, and b1, b2, and b3, or this is beta naught, beta 1, beta 2, beta 3. So if you see our equation on the top, this is what how it looks. Y hat is equal to, our beta naught value is this one, which is negative 32911.2367 plus B1 is 152.96. So let's stick to maybe 4 decimals. 9691 x1. So it depends on how many decimals you want. Minus beta 2 is negative 35375.7234 x2, and then the finally plus, so that is this expression, 5820.9518 x3. So this will be our equation for the regression. So this is the model you will use to make future predictions. So once we have this equation, is this equation good enough to make predictions? So how can you make, and how can you say that this equation is good enough to make predictions? So to do that, we discussed previously that for the entire model, if you are doing this is for entire model, if you are doing this is for entire model, if you are doing hypothesis testing, the null hypothesis is beta 1 is equal to beta 2 is equal to, in this we have 3 variables, so you will go until beta 3, that should be equal to 0. That means there is no relationship between y and x1, x2, x3, no relationship between. So if we don't have any relationship between y and any of the x's, y and x1, x2, x3, then you are not able to predict. So that's the reason why so this should be false, or this we should be able to reject it. If we reject it, then our model is good. And our alternative would be, if we reject this, that means our alternative would be at least one coefficient is different from 0. So what this means is, that means if one of the coefficients is different from 0, that means at least we have one factor or one independent variable that is helping us to make decision, or to make to get the value of y. So that is what is happening. So to do hypothesis testing, I said one of the ways we can use is f greater than f alpha, which is the critical value, degree of freedom 1, degree of freedom 2, and this is the degree of freedom of regression, and then this is the degree of freedom of error. So this is one way you can do say whether your model is good. If this is greater than, you reject H null and you will say your model is significant. Model is significant or good enough. So when we say our model is significant, it is good enough to make predictions. So the other way, this is the easiest way. Usually when you go to your higher level, you are just looking at p-values less than alpha. You reject H null and then model is significant again. So usually when you go to your higher education, this is what people look, and that they just make the conclusion that this model is significant or not. So again, this f value, this p value for the entire model, you are looking here in the ANOVA table. So this f significance, so if you see f significance, that is actually p value. So the p-value here is this one, and then you are asking yourself, is this p-value less than alpha? So alpha, if it is not given, you will assume it as 0.05. So currently the p-value is 0.00074. So let me copy that down. So the p-value here is 0.00074. Is this less than alpha? If alpha is not given, you will assume it as 0.05. So 0.05. Is this statement true? Yes, this statement is true, as 0.00074 is less than 0.05. You are saying reject H null. So that means you are saying all the variable, all the coefficients being 0 is this is a false statement. So at least one coefficient is different from 0. So this is a true statement. So if this statement is true, that means you are kind of saying this model is significant. So model is significant. When I say model is significant, I can use this model. So that is one way. So this is the easiest way which you can do. But if you wanted to do f greater than f alpha degree of freedom, so the first thing is, when you want to see the f value, test statistic value, so this is here, if you see, this is your f value, which is the test statistic value. So f value is let me again cross check. F value is 37.62. So 37.62. Now the next step is to calculate the critical value, which is this one. So f alpha degree of freedom 1, degree of freedom 2. So I know f alpha is 0.05. Degree of freedom 1 comes from regression. So I will go to our ANOVA table again, and this is our ANOVA table. I'm looking for what is the degree of freedom for regression. So that is 3. So the degree of freedom for regression is 3, and the degree of freedom 2 is this is the error. So you will kind of go and look for what is the degree of freedom for error, which is 5. So you are going to look for this value in your F table. So I'm looking for F 0.05, degree of freedom 1 3, and degree of freedom 2 as 5. So to look at this value, I will again go to our canvas, go to modules. In module 0, I will go to calculation aids, and then look for statistical tables, and then I will do enable editing. Currently I am in Poisson table. I wanted to go to F. So F table is we have 4 F tables: F.10, F.05, F.025, and F.01. So I am going to go to F.05. That is what our this thing is. So this is F 0.05, and then the degree of freedom 1 is 3, and the degree of freedom 2 is 5. So degree of freedom 1, if you see, that is this way, degree of freedom 2 is this way. So the degree of freedom 1 is our 3, and then degree of freedom 2 is 5. So I'm looking at value 5.4095. so that is my critical value. 5.4095 is my critical value. So again, F greater than F alpha, so F is 37.62. is it greater than 5.4095? This is a true statement, so you reject H null. So one of the ways we look at it is the F table looks something like this, and then you are saying this is 5.4095, and then this is the rejection region, reject H null, and if you see, this will be do not reject H null region. So this is do not reject H null. So if you see our test statistic, so this was the critical value. Now our test statistic value, which is 37.62, falls way to the right, which is 37.62. So you are rejecting H null. So that's how you are rejecting. So that means when you reject H null, none of the coefficients are all the coefficients are zero. That means they are not important. That means none of the factors are important. So if you do if you do not reject H null, so currently you are rejecting H null, that means alternative is true, that means one of the factors is true. So this model is the model which we said, this one y hat, this model is good to use. So the next question is which factors are good. You know, you wanted, it's not only you wanted to have this equation, but people wanted as less variables as possible to make accurate and still make accurate predictions. So they don't want so many variables at times. So we are asking ourselves, is x1 important, x2 important, which one is important? So when I say important, I'm saying is x1 significant, is x2 significant, is x3 significant? So that is how I'm going to ask myself. So to do that, one of the ways we do is we go and look at p-values. So usually for intercept, you don't touch them at all. So you are not concerned, it's just y-intercept, so you just can take those values directly, and you are not at all touching them. So the rest, you look at p-value, and if the p-value is less than alpha, then that factor is significant, and if it is not less than alpha, that factor is not significant. So if you see in this case, beta 1 b1 p-value is 0.00463. so let me write, so the factor b1. So now I'm doing null hypothesis for b1, or beta 1 is equal to 0. Alternative will be beta 1 not equal to 0. So if it is 0, no relationship, that means this is not significant, so we can't use this factor. So again I'm looking at p-value less than alpha here to reject H null. So what is my p-value? So let me see what's my p-value here. P-value here, this would be for b1 0.00463. so that is 0.00463. is this less than alpha, which is 0.05? This is a true statement, so that means you will say reject H null. That means this is false statement, so this is true. So beta 1 is important factor, this is a significant factor. So let's see other factors. So let's see b2. So that is the p-value is, again I will write the hypothesis for you so that it's important you understand. H null beta 2 is equal to 0. Alternative is beta 2 not equal to 0. So again you are looking at p-value less than alpha to reject H null. So let's look at what is the p-value here. So the p-value in this case is 0.2464. So p-value is 0.2, let me cross check, 464. 0.2464 is my p-value. Is it less than 0.05? So that is what I'm asking. So 0.24 is not less than, this is not less than 0.05. So this is a false statement. So p-value less than alpha is false. So what it means is you do not reject H null. So that means this is true. So this is a true statement. So beta 2 is 0. This is a insignificant factor. So this is not significant factor. So again, the other way you can go and look at this lower interval and the upper interval. You see, the lower interval is negative 104658.31 and the upper interval is 33906.87. So 0 lies within this confidence interval. So we can kind of say that beta 2 is almost equivalent to 0. Even though we have this value, we cannot surely say that kind of beta 2 with confidence. We cannot say beta 2 is not equal to 0 because 0 lies within this range. Same we can do for beta 3. So this is not important. So this is an not significant factor. So we will do the same thing, beta 3. So our H null is beta 3 is equal to 0, H alternative beta 3 not equal to 0. Again I am going to look at p-value less than alpha. So my p-value here is 0.3763. So again, so you might get confused when you look at what is this. This is a point estimate. You are giving the expected value. So this is the expected value and this is the range. So if you see for each one of them, the idea is you have a mean and then you have a range like we did in normal distribution curve. I will discuss that again once I finish the beta 3 evaluation. So beta 3 p-value less than alpha. So the p-value here is 0.3763. So I will try to change the color so that you understand which value I am using. 0.3763. So p-value is 0.3763 less than alpha is alpha is 0.05. So you are saying again 0.37 is greater than 0.05. So this statement is false. So do not reject. So this is again not an important factor. So this is true. That means beta 3 is 0. So this is not significant factor. So the main idea behind this is like for beta 3 I can draw a normal distribution curve and my average turns out to be the coefficient value, which is 58, this value 5820.95. So this turns out to be 5820 point, let me see, 95. since we said we wanted 95% confidence interval, so this value will be your lower bound and this value will be upper bound. So if you see the lower bound for confidence interval, again this is a negative value. So if you see this, that is 9596. So I will just use negative 9596.29. I think that's what this value is. Yeah, so the upper limit would be 21238. So this would be 21 positive 21238 point, let me check, 0.20. So you see it has negative and it has positive, so that's the range for 95% confidence. So 0 would lie somewhere in this. That's the reason we are not able to say beta 3 is not equal to 0 confidently. So because since 0, this is 0, 0 lies somewhere in our confidence interval, that means 0 as such when you collect data it's giving you beta 3 is 0. So that's why it is not a significant factor. So why this is important now, this means our equation we can reduce it to, as we know, this is our equation. This is our equation. Since we know x2 and x3 are not important factors, we can throw them out and we can just say our equation would be y hat is equal to negative 32911.2367 plus 152.9691x. So this only factor, the x1. So this factor is going to help us to determine the sales price of the house. So that is how we are kind of mm, reducing the factors. So the other two factors won't add any much value to it. So again, if they ask you this is how you are going to solve. If they ask you the confidence interval, your 95%, 99, you can just change here. So this lower 95 and upper 95 will be always the same. So this will be like if you wanted to change, uh, if you wanted like 99%, you will just do 99 here and you'll get 99% confidence interval for all the three slopes. Yeah, so this concludes my lecture on multiple regression. I will try to solve some more problems from Hawk's learning in my next lecture. Thank you.